All right, so 7, 8, 9, again, we're doing the sum and difference identities. This is problem type 3. Sum and difference identities, again, are right here. For example, if I have the sine of A plus B, I have the sine of A, cosine of B, plus cosine of A, sine of B. You're going to want to keep that handy while you do these problems. I'm going to write them on my paper, and so I don't have to flip back and forth, but you want to have that list handy as we work out these problems. I'm going to go over here. On these ones, we're going to draw our reference triangles. So first of all, we have the cosine of 4/5 in quadrant 4. So in quadrant 4, the cosine is going to be the adjacent over the hypotenuse, so I'm going to have 4 over 5. Using my Pythagorean theorem, a squared plus b squared equals c squared, so 4 squared plus b squared equals 5 squared. That means I'm going to subtract my 4 squared, 25 minus 16 is 9, square root of 9 is going to give me 3. This is going down, so it's going to end up being a negative 3. My other angle is in quadrant 3. Tangent is going to be the opposite over the adjacent. Here I'm going to have a negative over a negative, so my opposite side is going to be negative 3, my adjacent side is negative 4, and if I use my Pythagorean theorem, negative 3 squared plus negative 4 squared gives me 9 plus 16, which is 25, and the square root of 25 is 5. And we know the hypotenuse is going to be 5 then. Hopefully you're really good by now drawing those reference triangles. So now, if we look back at our formula for cosine of alpha plus beta, I'm going to have the cosine of alpha, cosine of beta. That's a plus, so this will be minus sine of alpha, sine of beta. So cosine of alpha, that was easy. They already told us it was 4/5. Cosine of beta, cosine would be the adjacent over the hypotenuse, so negative 4/5. Minus the sine of alpha. The sine of alpha is up here, negative 3/5, opposite over adjacent, or opposite over hypotenuse, excuse me, opposite over hypotenuse. And the sine of beta, opposite over hypotenuse, negative 3/5 again. So here we are going to have negative 16 over 25 minus, that's going to be positive 9 over 25. Negative 16 minus 9 would give me negative 25 over 25, which simplifies into negative 1 then. So my answer, negative 1. Number 8, we're doing sine of alpha minus beta. Alpha is going to be 5/13. It's in quadrant 2. So quadrant 2, my sine is going to be the opposite over the hypotenuse. So 5 and 13. So 5 squared plus b squared equals 13 squared. So I'd have to subtract my 5 squared, 169. 169 minus 25, 4 would be 144. Square root of 144 is 12, but it's going backwards, so that's got to be a negative 12 there. So the other one's in quadrant 3. So quadrant 3 would be back here. It's my cosine. My cosine is the adjacent over the hypotenuse. So my adjacent is negative 15, my hypotenuse is 17, and so negative 15 squared plus b squared equals 17 squared. Negative 15 squared is going to be 225, so 225, 17 squared is going to be 289. So if I subtract my 225, I get 64. Square root of that would be 8. I'm going down, so I have to have a negative 8 there. So I've got my two reference triangles. Now I need to worry about doing the sine of alpha minus beta. That's going to be the sine of alpha cosine of beta minus, and then I'm going to have, I'm going to look that up there, cosine of alpha, switch that around, and sine of beta then. So cosine of alpha, or sine of alpha, cosine of beta, cosine of alpha, sine of beta. So looking here, sine of alpha was the 5/13. Cosine of beta, well, cosine of beta, negative 15/17. Minus cosine of alpha would be negative 12/13. Sine of beta is going to be negative 8/17. And so we have to multiply that out. 5 times negative 15 would be negative 7, or negative 17, negative 75. 13 times 17 is 221. Minus, here we have a negative times a negative. 12 times 8 is 96. And 13 times 17 again is 221. So we're going to take negative 75 minus 96. We get negative 171 over 221 then. And that's going to be my answer. Number 9, same kind of thing, doing the sine of alpha plus beta, starting off with my first angle in quadrant 4. My cosine is the adjacent over the hypotenuse, so 5 over 13. So 5 squared plus b squared equals 13 squared. I'm going to subtract my 5 squared. 169 minus 25 was 144. Square root of 144 was 12. It's going down, so it's got to be negative 12, right? And on the other one, we are in quadrant 2. Quadrant 2, we are doing the sine, so opposite over hypotenuse. So 12 over 13. So we're going to say 12 squared plus b squared equals 13 squared. 144, 169, so subtract my 144, gives me 25. Square root of 25 is 5, but it's going backwards, so it's got to be a negative 5. Got my two reference triangles. I got to do my sine of alpha plus beta. So I'm going to have the sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. If I look up my formula. So sine of alpha, negative 12/13. Cosine of beta, negative 5/13. Cosine of alpha, 5/13. Sine of beta, 12/13. So negative 12 times negative 5 would be 60. 13 times 13 is 169. Plus 5 times 12 again is 60 over 169. 60 plus 60 is 120 over 169. So 120 over 169 would be the sine of alpha plus beta.